Hello, my name is Alejandro. For exam number 2, I'm going to be working with 2114. Okay, first question. The electric dipole moment of a water molecule is 6.13 to the power of 10 minus 30 cm. You place a water molecule in uniform electric field of magnitude 3 times 10 to the power of 5 NC with the dipole moment vector at an angle of 50 degrees from the direction of the field. Calculate the magnitude of the torque on the water molecule. Okay, we start. Dipole moment is given to us. And it's C.13 to the power of 10. I'm sorry, times 10. Electric field of magnitude is also given to us. And the angle of 50 degrees. And we need to find torque. Okay, there is a relationship between all of what is given to us. And we should know that torque is equal minus, no, I'm sorry. Dipole moments times electric field times sine of an angle. Now all we have to do is plug in. Of 50 be roughly part B. Calculate the potential energy. Calculate the potential energy for the water molecule. Suppose that U equals 0 if the dipole moment vector is an angle of 90 from the direction of the field. Okay, we need to find potential energy. We know the angle we know is not 90 degree, so it cannot be 0. What another info we have here? Potential energy. We know the formula is minus minus dipole moment times electric field times cosines of the angle. The angle we know is 50 degrees. Dipole moment we know is 6.30. Energy field was also given to us. And cosine of 50 roughly negative 1.18 joules. Okay, part C. An electric dipole is in a uniform electric field of magnitude 8.50 times 10 to the power 4 Newton Coulomb. The charges in the dipole are separated by 1.10 times 10 to the power minus 10 m. And the torque on the dipole when its dipole moment is perpendicular to electric field is 0.60 times 10 to the power minus 26 newtons meter. Calculate the magnitude of the charges that make up the dipole. Okay, we need to find charges. We need that, what is given to us. Electric field is given to us. And it's 8.50. The charge in the dipole are separated by torque is given to us and is the charges in the dipole are separated. Distance is okay. Calculate the magnitude of the charge that make up the dipole. Charge in the okay. We know we know the equation to find dipole moments. is given by charges times distance. Mm, Okay, we're also given the torque. We know the torque formula, we used it before, is we're also given the angle perpendicular to electric field. Perpendicular will be an angle of 90 degrees. We are gonna find the dipole moments with this formula. Mistake. Formula is sine angle. So of 90, that's one. Okay. Okay. This will be the dipole moments. And now with this information, we should be able to find our charge. That's uh that's our answer for charges, the magnitude of the charge. Okay, we are gonna be working with part D that says place a molecule in uniform electric field of magnitude 1.20 times 10 to the 5 NC. It requires 4.60 times 10 to the power minus 25 joules of work to change the orientation of the molecule's dipole moment from parallel to the field to the opposite to the field. Calculate the magnitude of the dipole moment. Okay, on this one, we are given electric field, and its work is also given to us. Intention of the market dipole moment from parallel to opposite to the field. Dipole moment from parallel to the field. So the field is angle. We have two angles. Initial angle and final angle. Initial angle is gonna be 0 degrees. Final angle is gonna be 180 degrees. We are gonna be working. We're gonna need to find the dipole moment. We need to find the dipole moment. We know our dipole moment is given by formula dipole. It's gonna be given by formula we have okay, we are gonna be working with potential energy formula. Initial potential energy. Initial potential energy. We not can find. We're gonna use the first angle that we got that is 0 degrees. Cosine 0 is 1. Potential energy final cosine of 180. We know it's -1. Okay, we're given work, and we should know that work is equal change of potential energy. Um, so we are gonna use this same formula to find type of moment. That is what we need. We already have electric field, so we should be able to plug in and find the answer. Also, we have the work. Hopefully, and this will be the answer for the dipole moment, the magnitude of the dipole moment. Okay, part E. The ionic molecule potassium made out of a positive potassium ion of charge plus E equal 1.60 times 10 to the power of 19 C, and a negative bromine ion Br of charge minus C equals negative 1.60 to the power uh, to the power 19C, has an electric dipole moment of 3.50 times 10 to the power minus 29 cm. Calculate the distance between the two ions. Okay, for this one, what is given to us? We need to find the distance between the two ions. The two ions. Dipole moment is given to us. Also given to us is charge. Okay, there is a formula that is a dipole moment equal charge times distance, which is what we need. So there is a relationship between those three. We should rearrange and plug in to solve this one. Dipole moment is given to us. Charge we need to find the distance between the two ions. We move this part to one side, to the other side, let's down here. Roughly 119, 10. And we have the distance. Okay, part F. Present a point along the axis that connects the ion. The electric field due to the key VR molecule has a magnitude 8.00 times 10 to the power of 4 Newton's column. How far from the center of the molecule is this point? So basically what we need to find if a point is what is given to us? Electric field is given to us and is electric field is given to us and is 8.00. Okay, electric field on an axis is given by the formula where P is a dipole moment, and we have that. We have it. It's given to us. The moment this one is permittivity of free space. And we should know that is 8.5. Sorry. It's 54. Okay, we have the electric field is given to us. And I believe that's all we need to solve this one. We are going to rearrange. We're going to plug in all the value we have. Or and now it's just a matter of calculate all what the this we have here. Okay. Gonna be and that would be roughly the answer. Now here concludes my test.